So here are some of the key concepts for graphing quadratics. So the graph of a quadratic function is a parabola. The parabola is a smiley face when a is greater than 0. That means that the function has a minimum. The parabola is a frowny face when a is less than 0. This means that the function has a maximum. To find the vertex, compute negative b over 2a, and that gives us the x-coordinate of the vertex. So we're going to plug the x answer into the function in order to find the y-coordinate. The maximum or minimum value is always the value from the y-coordinate of the vertex. The axis of symmetry is a vertical line that runs through the vertex. The equation of the line is always x equals negative b over 2a. The domain of any quadratic is all real numbers. The range of a quadratic will either be y is greater than or equal to the y value of the vertex when the vertex is a minimum, y is less than or equal to the y value of the vertex when the vertex is a maximum. To graph a quadratic, find the vertex, and you need at least 2 additional points. Okay, the y-intercept is a good point to use, and that's always going to be equal to 0, c. So here we want to find the vertex, the axis of symmetry, the max or min value, the domain, and the range of the following functions. So first thing I want to do is I want to find my vertex. So I always start with x equals negative b over 2a. That's going to give me the x value of the vertex. So I'm going to plug in negative b is going to be negative 6 over 2 times a, which is negative 3. So this gives me negative 6 over negative 6, which equals 1. So the x value of my vertex is 1. So now I'm going to plug it in and solve for y. So I'm going to do negative 3 times 1 squared plus 6 times 1 minus 9. So y is going to end up equaling negative 6. So my vertex is going to be the point 1, comma, negative 6. The axis of symmetry is always x equals the x value of the vertex, so x equals 1. Okay, it's important that we write x equals and not just 1. This opens down because the a is negative, so as a maximum at negative 6, because that's the y value. The domain, since it's a quadratic, is all real numbers. And then the range, since this opens down, y is going to be less than or equal to the y value of the vertex, which is negative 6. Okay, so if we look at the next problem, again, I'm going to start with x equals negative b over 2a. So it's going to end up being a positive 8 over 2 times 2. So 8 over 4 gives me 2. To find the y, I'm going to plug 2 in. So it's going to be 2 times 2 squared minus 8 times 2 plus 1. And I end up with y equals negative 7. So here my vertex is going to be 2, negative 7. My axis of symmetry will be x equals 2. This opens up because a is positive, so it's going to have a minimum at negative 7. The domain is going to be all real numbers, since it's a quadratic. And then the range, since this opens up, we're going to have y is greater than or equal to the y value of the vertex, which is negative 7. So now we want to graph. So what we're going to do is first identify a, b, and c. So from this function, a is what's in front of the x squared term. So a is going to be 1, B is going to be 2, and C is going to be 3. Next, we want to find the vertex, so we're going to do negative b over 2a. So we get negative 2 over 2 times 1. So negative 2 over 2 equals negative 1. Plug that in to find the y. So I'm going to plug in negative 1 squared plus 2 times negative 1 plus 3. And that equals 2. So my vertex is going to be negative 1 comma 2. Find the y-intercept, so that's going to be 0 comma c. So my c term is 3, so 0, 3 is my y-intercept. Is this going to open up or down? Well, the a value is a positive, so this is going to open up. So if we go to plot the points that we have the vertex is negative 1, 2. I have my y-intercept, which is 0, 3. And because of symmetry, I know that the point negative 2, 3 is also going to be on this graph. So I can find that third point. So I need the vertex and 2 additional points. And then I have my parabola. Okay, so here, again, first identify A, B, and C. A equals negative 2. B equals positive 2. C equals negative 5. So we're going to find the vertex. So let's do x equals negative b over 2a. So we get negative 2 over 2 times negative 2. And this is going to end up being 1/2 as my x. So I'm going to plug in 1/2. So negative 2 times 1/2 squared. When you're plugging these in, make sure you follow the order of operations. So you're going to do the 1/2 squared first, then times the negative 2. So when you do this, this ends up being negative 7/2. So my vertex is 1/2 comma negative 7/2. Then the y-intercept is 0 comma c. My c term is negative 5. So 0, negative 5. Does this open up or down? Since a is negative, this opens down. So now I'm going to graph the points that I know. So 1/2, negative 7/2. So that's going to be about here. And then I know 0, negative 5. So 1, negative 5 is also going to be a point because of symmetry. And there's our graph.